All right, welcome to today's special Community IT webinar on Intel side channel vulnerabilities. It's a little bit of a departure from our usual content on Wednesdays, but we're glad for the opportunity to talk about this important topic with you all today. My name is Matthew Eshelman. I'm the Chief Technology Officer here at Community IT. Community IT is a employee-owned company that has served the nonprofit community since 1993, helping organizations use technology to meet their mission. And I'm happy today to be joined by my colleague, Galen Wenger.
I'm Galen Wanger. I'm the Centralized Services Manager at Community IT, which means that I work a lot with the patching, antivirus, and security landscape for our clients here at Community IT. Happy to be here.
Great. So Galen's here kind of as a special guest because of his depth of technical knowledge related to how we patch and manage the systems that we maintain here at Community IT. So we support over 4,000 endpoints. So the issue of the Spectre and Meltdown vulnerabilities are particularly important to us as it relates to the security of the networks and the clients that we support. So a little bit of background, and I know judging by the surveys that went out, folks have a general awareness of these vulnerabilities. So specifically, Spectre and Meltdown are significant vulnerabilities that affect nearly all processors manufactured since 1995. So this is a really big deal. Potentially, I don't know, once in a lifetime type security vulnerability. So this vulnerability or these vulnerabilities were discovered by Jan Horn and Paul Coker, along with some additional security researchers. So Google Project Zero was one of the primary kind of research teams on this. And then there's a very good website with kind of much more detail than we'll get in today. But those papers are available right at Meltdown Attack/Meltdown and Spectre Attack /Spectre. So they have more of the technical details that are related to the vulnerability and the exploits as well. So fundamentally, these are exploits that expose information in memory. And we'll talk a little bit more about kind of how they do that. But essentially, they expose and access information in memory that they shouldn't have access to. So everything in the processor architecture is really abstracted and should have tightly controlled rules around which processes and roles and systems can access what information. And then these attacks exploit some design flaws and vulnerabilities in how processor architecture is established. So there's a really great article that I would encourage everyone to take a look at. Is the Strategy article. Our CEO is a big fan of Ben Thompson, and so this is his take on kind of fundamentally how this vulnerability is exploited, and then perhaps some analogies that are helpful when thinking about how to talk about this in a little bit of layman's terms. So it's a little bit of an overview of the vulnerabilities as they exist. So we'll first start off with Meltdown. And so Meltdown is a vulnerability, is named in that it melts down the security boundaries that are normally enforced by the hardware. And this is essentially as a flaw in the system. So, and it allows a program to access the memory of other programs or the operating system. So, so essentially, the hardware-based isolation, kind of has a permission bit, and it's secure, and so processors are always mapping the access of the processor and the kernel into different virtual address space. And so what happens is this vulnerability can be exploited so that a program can be used to read memory in which it normally would not have access to. So this fortunately can be fixed by an OS update, and those OS updates have already been released for most kind of contemporary operating systems starting in the beginning of the year. We'll talk a bit more specifically about updates and updating in general as we get into the presentation, but just kind of know right now that is an OS update, and protection against Meltdown essentially has been addressed. It's a little bit easier to kind of respond to. So this is a little bit of an example of a code snippet from the Meltdown site. I'm not confident in all of the details about how this is working, but essentially the code is used to trick or show um, and expose the contents of memory in a location that would otherwise not be accessible by the system. So it is able to kind of trick the processor into giving up that information that would normally be privileged, and so it can be read by read by an application running on the computer. And so this affects, again, all systems, so Mac, Windows, Linux. So everything is vulnerable to this attack. And so practically speaking, what this could mean for you as an end user is that the through running a bit of code here, we can see that in a terminal window. So this is representative of a a process running on your computer. The code can be executed on the terminal, and then in the password manager up ahead, we'll see the password that is typed to be executed by the by the system here. So let's see if we can get this video to run and take a look at what that animation is going to look like. All right, well, it looks like the animation is not going to run in my embedded video, but essentially what you would see here is a little bit of code run, and after the code is run, the user goes up into the unlock password manager password, and then is able to simply type in, type in the password, and then the output of that password is actually displayed in the terminal window. So it's a pretty instantaneous, fix to be able, or vulnerability that's exploited where you can kind of see the contents of the password itself. So, from a practical point, if your computer was infected with a vulnerability or affected by a vulnerability that was able to exploit this, the attacker would be able to, read the contents of your passwords. So again, if as we've gotten some questions ahead of time, and I think we'll cover most of the questions that were answered. Please go ahead and chat those questions in, and we'll answer them as we go along or find some time at the end. So again, please ask questions as you think of them, and we'll get to them as we go. The other vulnerability that was uncovered by these security researchers was a vulnerability called Spectre. And Spectre is, the name is based on the fact that it's on the root cause, which is speculative execution. Spectre, again, kind of tricks applications into accessing different locations in memory. And this one's a lot harder to exploit, but it's also harder to patch. So this is more like a design flaw in the processor architecture itself. So essentially, processors are very, very, very fast, and they see they're kind of very dumb. They just do basic things. They're making a decision 0, 1 on or off, but they can do that billions of times a second. So in order to as a way of taking advantage of the processing capacity, processes are essentially running lots and lots of processes or in parallel, and so some of those processes they don't complete, but they're kind of checked, and then the contents of those decisions are dumped out of memory. The problem is that Spectre exploits is that through the vulnerability they can actually the malware can kind of go back and check those memory registers that aren't before they get flushed out of the memory. So we're making a bunch of decisions as a processors. We're kind of expecting we're being speculative in terms of what the user or what the computer program is going to do, and if it doesn't do that, no big deal. We're just going to dump that out of memory. But what this Spectre vulnerability kind of allows a computer or an application to do is to kind of pull the contents of that data out of memory before it gets flushed by the system. So again, it's and this is more reflective of the kind of a fundamental design flaw. So this is a speculative execution is a feature of modern processors. It's allowed us to have the tremendous gains in processing power that we've seen over time, but the processor designers didn't necessarily envision how this potential speculative execution could be exploited by malicious processes that wanted to take advantage of the when and the how data was executed as part of the processing power. So again, a little bit of a code snippet in terms of the example of looking at the contents of memory, shifting some things around, and then exposing memory in a location that should not be accessible by that program or application. So these are really, I think fundamental and really shocking flaws that exist in the systems that we all know and use. I think to my knowledge, I don't know, Galen, if you've seen other security research, like these have not been exploited out in the wild yet. But like with other vulnerabilities like Eternal Blue that exploited vulnerability in the SMB stack, it's only a matter of time before these vulnerabilities get kind of get out and really get exploited by the malware writers, nation states, and attackers that have a financial interest and a vested interest in terms of exploiting computer systems. So it's only a matter of time before these will be incorporated into attacks that we're going to see on our networks. That we all support and manage. So with all this kind of scary, kind of fear and uncertainty in terms of, hey, we got these like fundamental flaws that affect every processor that we use, that we run, our phones, our computers, our laptops. So what do we do? And the first note I have here is really patch. And I think this represents a shift in terms of how we as IT professionals think about patching. I know I've been with community IT for about 16 years, and probably up until even 5 years ago or so, we were really thinking of like, well, patching is like, well, do we have to do it? It breaks things and it takes time, and it's not something that we did as our first kind of go-to step. I think that's really changed dramatically over time until now. We're very much a patch first and update first mentality. A lot of these security vulnerabilities exist in out-of-date software. So vendors are always updating and providing updates to software to address vulnerabilities that have been identified. And so patching is much more critical now in terms of protecting your network than maybe it has been in the past. So there may be issues with patching, but we're still, we've really taken the approach of it's important to patch first because security is important. And other issues, we can work around. So patching is really, the best way. And the good news is, in general, there are patches available for this. So, Galen, I wonder if you could just talk a little bit about, what systems are, available to be patched.
Sure thing. And to address your previous question of are there already exploits in the wild for these vulnerabilities, I have seen some researchers have indicated that they are seeing what they would call proof of concept code to attack these vulnerabilities. So in other words, some people are trying to figure out how to exploit these vulnerabilities, but I'm not aware that anyone has actually seen kind of a quote unquote weaponized version of these vulnerabilities that's actually being used to maliciously attack and exploit computers. In terms of the patches available, we are looking at a situation of where we're patching basically everything. So, these exploits, what makes them a little unique compared to other security vulnerabilities that we deal with is that these are hardware-based vulnerabilities rather than software-based vulnerabilities. We're usually, there are vulnerabilities in operating systems or maybe in the applications that we run, and those vulnerabilities are limited to just Microsoft Windows or OS X. In this case, we have a hardware vulnerability. That also makes it trickier because, well, it's not very easy to replace the hardware, and all the hardware, all the processors that we've been deploying in the past 12 years are vulnerable. So we're having to kind of work around and fix these issues, these hardware issues on the software side. So it's pretty tricky business, I think, for technology professionals at both Intel and Microsoft, et cetera, to put together these patches. Patches are available for basically almost all operating systems. So all supported versions of Windows desktop products, Windows 10, 8.1, and 7. If you're running Windows XP, this is a reminder that it really is time to move on from that. For Windows Server, there are patches available for 2016, Server 2012 R2, and Server 2008 R2. There are not patches available yet for 2008 R1 and 2012 R1. My understanding is that those patches will be released in the future. I have not seen anything from Microsoft that says they will not be releasing patches for those versions of the operating system. For ESXi, if you have a virtual host in your environment, we do need to patch those as well. So that'd be version 6.5, 6, and 5.5, and then the 3 supported versions of OS X. These patches have all been, the Microsoft patches were out really at the beginning of the month, in beginning of January. OS X released their patches, kind of during the month of January. What we have seen, and what I think we'll continue to see, is that these patches will continue to be improved, partly because, again, this is pretty tricky business. So I know for the Windows products, the original patches they released on January 3rd. A couple weeks later, they released an updated version to help address some of the issues that the earlier patches may have introduced. My sense is that we will continue to see kind of improvements to these operating system patches over the next few months. So what improvements need to be made? Well, one area of concern is the potential performance impact. So the vulnerabilities that we're dealing with here are really, it's attacking ways that the computer hardware was designed to make things go faster. So, Spectre is addressing speculative execution. So the computer is trying to guess ahead of what we might want to do and do some of the work ahead so that it seems faster to us than when we're taking an action on the computer. And now we're having trouble with that. So as we try to, fix some of these issues, we are losing potentially some of the performance gains that we had. And so I think as we see later versions of the patches come out, hopefully it will address some of those performance issues. The message I would say is definitely go ahead, patch now. We need to patch now, and hopefully we'll see improvements in the future. In terms of the direct performance impact, the analysis that I've seen is that it depends on the processor generation. We often refer to them based on the generation code name: Broadwell, Skylake, Ivy Lake. If you read computer specs, you may have seen those names, or maybe referring to like Intel 4th gen, 5th gen, et cetera. That's what we're referring to. My understanding, and Matt, correct me if I'm wrong, the performance impact is going to be worse on older versions of the processors. So I would say, I believe it's 4th gen and earlier processors, they're seeing a larger performance impact than on, say, processors released. And that would be processors maybe 3 or 4 years old and older are seeing a larger performance impact than newer processors. Matt, is that your understanding?
Yeah, that's correct. So, older generation processors are more significantly affected by this. If you do some Google searching, you'll see different vendors, particularly cloud information as a service, vendors have a lot more insight on how this has impacted their network. So older processors are affected by this, to a greater degree than, more contemporary computers. So for example, on my system, I did some performance benchmarking, and I think before I installed the update, I ran the benchmark test. I installed the updates, I ran the test again, and on the processor side of things, there was like a 2% decrease in the processor benchmark. Older computers, they're talking about realistically like a 20 or so % decrease in the processor score. Now, obviously, performance includes a lot more elements other than just how fast is a processor. Disk, I/O, RAM, memory, and kind of all those other things can come into it. So it's not an exact science. It's not if you install this update, you're going to lose 20% on your specific workload. So it is workload dependent, but the unfortunate answer is that, yeah, if you have a system that's like 3, 4, 5 years old, at the end of this process, you may have a noticeably slower system. If you have a computer that was purchased, a year ago, you're probably not going to notice anything, but it does impact older processors more significantly than more recent processors.
Thanks, Matt. And I think the other point to highlight here, and it's a good segue into the BIOS updates. There's two levels to these updates. We have operating system updates and then BIOS updates. And the BIOS update may be where you see the larger performance impact, and not just with the operating system update. So let's talk about the difference between those two updates. So in the operating system, they are trying to patch as much as they can. In particular, the operating system updates is going to include updates to address the Meltdown vulnerability, which is, my understanding is that it's easier to exploit than the Spectre vulnerabilities. And so very important to take care of those. On the BIOS updates, so to fully address Spectre, we also need to update what's called the microcode. So basically the firmware or the, and it's packaged together in the BIOS, but the kind of that low-level code that's kind of, governing how the processor operates. And so that requires, Intel is releasing updated microcode, is what they call it, to the computer manufacturers, Dell, Lenovo, HP, and they then package these updates as BIOS and firmware updates that we all then need to install. So Intel released microcode updates in advance of the disclosure of this vulnerability, with the intention being that updates would be available for at least the majority of systems prior to folks finding out about this publicly, about these vulnerabilities. It was later learned as folks started installing these BIOS updates, the original ones, is that it was causing sometimes significant issues with the stability of the computer, depending a little bit on the processor generation, but we were seeing more blue screens, so the computer would stop running and need to be rebooted. And I know we patched a couple of computers at Community IT right away to do some testing, and we have seen that those computers have had some stability issues since those BIOS updates were installed. So Intel and the computer manufacturers pulled all of those BIOS updates, and Intel has been working on releasing a new fixed version of the microcode that both fixes the security issue here, as well as doesn't actually break the computer stability. So those updates are, I don't know if trickle is the right word to use necessarily, but they are trickling out from Intel to the computer manufacturers. I was looking at the Dell pages today. Dell has BIOS updates available for just 2 server models, so not very many when you consider the several generations of server models that they'll be deploying updates for. And I'd say maybe a couple dozen workstation models. So the vast majority of computers do not, at least for Dell, do not have a BIOS update available yet. So we're waiting. Hopefully, I don't have any insider knowledge on how long it will take for all of these BIOS updates to be released. It's something to keep an eye on. But hopefully we'll see the majority of supported computers have a BIOS update available for it here in the next month or two. And we'll need to go ahead and want to deploy those BIOS updates to the computers that we all support. Generally speaking, a BIOS update does require a computer reboot to apply. It does. If we have a laptop, we do have to have it plugged into power, and so it is a little bit more of a significant update. But it's important. It's necessary to fully patch the computer. The last note there is if you have servers in infrastructure as a service, so Amazon, Microsoft Azure, follow up with or look at the documentation available from those providers on what you need to do to make sure that your servers in that environment are protected. Obviously, they should be taking care of the quote unquote physical layer, so their equivalent of the BIOS update, and all of the mainline cloud providers have already taken some steps to protect their environments. You will, generally speaking, you are responsible for the operating system level, so you will need to install those operating system patches. And as we'll find out in a little bit from Windows Server, there are some steps you need to take to enable those mitigations.
Yeah. So, as Galen mentioned, this is something that I think Intel has, I think, fumbled a bit. I mean, in terms of releasing microcode updates early in the month that were just not stable. So, I'm in that camp of early adopter in terms of installing an early update for the BIOS for my computer, which is now a lot more unstable than it was before. So I'm in the camp of having my computer blue screen every couple of days or so, and I'm currently waiting on BIOS updates. So we I think are a little bit gun shy to kind of rush out and install these updates when they come, uh, as I think most people in the industry are. So we want to take a measured approach to ensure that this next round of updates does in fact fix the issue and provide stability. Intel has taken a bit of time. I think they originally pulled the updates around the 22nd of January, and so now they're just starting to re-release things here. Now that we're February 8th, so it's been a couple of weeks for them to kind of do the re-engineering and redeployment. So, again, patching is important, and so we'll talk a little bit about the steps that are required for patching, and it is different between workstations and servers. So we'll just take a look at the workstations first, and Galen maybe can walk us through the steps, because it is actually a little bit more complicated than just installing the Windows update, as there's a couple more pieces that have to be in place for this all to work.
Sure. So the first note that we see there is that we have to confirm antivirus compliance, and this is a pretty unique thing. Actually, this is the first time I've ever seen anything like it in Windows patching. So when Microsoft put together these updates to address Meltdown and Spectre, they found that in some cases, the way in which the antivirus software, some antivirus software, was accessing, protected areas of the computer in order to provide protection and guard against malicious processes. Some of the ways in which it was doing it, when these operating system updates were applied, it would cause the computer to stop working, fail to boot, and you have to go through recovery methods to be able to get back into the computer. So they have it set that you will not be able to install the January updates for Windows, which include the protections for Meltdown and Spectre, or any subsequent updates until there is a key set in the registry that signals that your antivirus is compliant. What we found is that, in most cases, current antivirus providers, their antivirus was either compatible already or only needed some minor changes to be compatible, but they weren't always deploying the registry key automatically themselves. At Community IT, we use WebRoot Secure Anywhere antivirus. In that case, the version that was already deployed in January was compatible, but they did not WebRoot did not automatically set the registry key itself until the version that was released really actually just this past week. So we were able to go ahead though, and because we knew that the antivirus was compatible, we manually deployed that registry key using our computer management system, and we're then able to go ahead and install the January patches. Now that we're into February, really, any supported antivirus solution should be setting that registry key automatically, but that's something to check with your antivirus provider. And the other way to know whether or not it's on there is just, have I installed the January updates yet or not? Because it won't, Windows Update will not even offer the January update until that registry key is set. So we're confirming our antivirus compliance. Also, if you have any computers that are not very tightly controlled and may have extra or additional antivirus software installed, maybe it was a computer that was previously unmanaged and had an antivirus program that was came pre-installed on the computer but hasn't been supported since, this is probably a good time to go ahead and clean those up, because we don't know what we don't know, and it could be that that antivirus system is incompatible. So after the registry key has been set, either manually with our automation tools or by the antivirus solution, we then go ahead and install the Windows update. And that update comes through normal patching channels, and so whatever you're using for regular Windows patching should work for that once that registry key has been installed. And then the last step, which we already kind of talked about, is that we'll need to install BIOS updates, and we're waiting in many cases for those BIOS updates to be available. So a couple notes on that process for installing BIOS updates. Our patching systems, for whatever reason, they may or may not support deploying BIOS updates. But in those cases, it is possible often to use a hardware vendor tool from Dell or Lenovo to deploy the BIOS to our enterprise class workstations or business class workstations. So what I mean by that, if we look at the Dell line, they have a tool called Dell Command Update that you can use to update both drivers and the BIOS on business computers, so Latitudes, Optiplex, and so on. But that tool does not work on home models. So if you have computers that maybe were sourced from outside of normal business channels, you're probably looking at a manual update there. But again, if you don't have a system in place for updating the BIOS, now is a good time to start looking at that so that you're ready to deploy the BIOS here in a few weeks. The other thing to keep in mind is that we're all more security aware now, and so we have BitLocker deployed a lot more often to provide encryption to our laptops. When we update the BIOS on a computer that has disk encryption through BitLocker, we need to do one of two things. So ideally, we will disable the key protections on BitLocker before installing that BIOS update. And what that does is that basically takes the encryption key and puts it in a special place in the computer that after the BIOS update is installed, it will still be able to, the computer will still be able to access the encryption key. Because when we install a BIOS update, it kind of breaks that kind of security layer that we have for BitLocker. If we don't do that, if we don't disable the key protections prior to installing the BIOS update, then when we boot up the computer, we're going to be asked to enter in the recovery key, which is A, very long, and B, hopefully you know your recovery key. If you don't, then you'd be in trouble there. So just if you have BitLocker in place in your environment, please make sure to kind of factor that into your BIOS updating plans.
Mm-hmm. Yeah, so I know we have a range of attendees on the webinar today, but so for those of you that are already clients of Community IT, this is something that will be delivered automatically through our management platform. So the Windows patches and the keys have already been deployed and updated, and so now we're waiting on the vendors to provide those BIOS level updates for the workstations in your environment. So those updates will be forthcoming. And we'll talk a little bit more at the end of our presentation about just how do you check and how do you actually know if these updates have been deployed. So for Community IT clients that for the workstations, these updates for Windows have already been deployed, and BIOS level updates will be coming and be delivered automatically through the platform. So workstations, I think in general, even though it's a multi-step process at this point, is fairly straightforward, and we have good tools and processes in place to do those updates. Servers, on the other hand, are a little bit more complicated, particularly for organizations that are in more of a virtualized environment. So we'll just kind of talk through that process for patching servers as well.
Thanks, Matt. So looking at the first two steps there, antivirus compliance and deploy the registry key, that's the same process that we went through with the workstation, so we don't need to cover that, and installing the Windows update. From there, then we have some potentially extra steps related to the hardware if we're using virtualization, so both Hyper-V and VMware ESXi. For those situations, so we'll look at Hyper-V first. So you need to install the Windows updates both for your virtualized guest computers as well as the Hyper-V server. And then you're going to need to actually, let me back up, excuse me. After we install the Windows update on Windows servers, there is a key distinction or key difference between workstations and servers. On workstations, Microsoft enables the protections automatically in the operating system for Meltdown and Spectre. On servers, because there, because there is a potential performance impact to these fixes, the mitigations are not enabled automatically. in the operating system, and we have to instead set registry keys to enable those mitigations. I think the logic here is that on servers we're more likely to see high utilization workloads, say like a taxed database server that could experience significant negative impact from the performance impact from the patches, as well as servers. We have a little different security landscape. We have anywhere from, say, remote desktop servers, which are highly vulnerable because any staff member can log into the server, and they may be using that remote desktop server to do general web browsing, and so there's a lot higher risk of insecure code running on that computer that could be used to exploit these vulnerabilities. But we also have some servers where maybe they're in a highly secure environment, maybe they are kind of cut off from the rest of the network, and we're able to weigh our security challenges here and make our own kind of judgment on whether or not we want to enable those mitigations. So in general, though, we should be enabling the mitigations unless we have a very good and well-considered reason not to. So after we install the Windows Update, we're going to, in the registry, enable the mitigations on these servers, and then we're going to reboot all the servers. And then after that, we need to turn our attention to the hypervisor, so that'd be Hyper-V or ESXi, as well as the physical hardware that it's running on. So we're actually going to completely shut down all of the guest servers at that point, most likely. And then we are going to, update. Let's start with Hyper-V. We're going to update Windows on the Hyper-V host, and we're going to enable the mitigations. And then we are going to also install the BIOS updates once they're available for the physical server. And we're going to boot everything back up, and we're going to make sure that everything comes up as expected. And then we're going to turn the guests back on those computers. Excuse me, on those servers. So the key distinction there being that in order to fully patch this vulnerability, we have to completely shut down the guest environment or guest server and boot it back up. A simple reboot won't fully enable the mitigations there. And there you can see, actually, I guess I went out of order here. The last note there, it says enable the side channel registry key remediations. So that would be what I mentioned there in terms of enabling the mitigations on the in the operating system of both the host server, if we have a Hyper-V server, as well as all the guest servers. Looking briefly at VMware ESXi, it's similar in that after we've updated our guest servers, we're going to need to apply an update to VMware, and hopefully we're in a supported version, so that'd be 5.5, 6, and 6.5. Then after we do that, it's important to take a note at the hardware version of our guest computers. There is a hardware version associated with all of the virtualized guest computers there, and it usually, unless you've been updating them regularly as you install updates or upgrades to VMware, it's equivalent to whenever whatever level or version of VMware was installed when you first created that server. VMware has said that older VMware hardware versions have a greater performance impact than newer ones. So basically we're looking at, we want to be on a VMware hardware version of 9 or above. So that means you may be running an additional process to update the hardware version of that guest server before you power it back up. So suffice to say, it's a lot. It's more work. Particularly if we're in a smaller environment where we aren't in a big data center where we may have a lot of automation tools. We could be looking at some manual work to address this on the server side. Here at Community IT, we're automating some portions of this that we're able to do with our management platform, but particularly for the ESXi work, we're looking at some manual steps taken by a technician to fully complete that update process.
Yeah, and I think what this kind of level of update shows, both in terms of updating the hypervisor, but then also updating kind of the underlying BIOS. Unless you're in a kind of a higher end virtualization environment where you've got the ability to move machines in real time between hosts and have shared storage, this can be a bit a larger downtime event because you'll need to take down the hosts, do the updates, kind of bring everything back up, reboot it a couple of times, and so it can represent a pretty significant body of work to kind of do all the updates and all the steps. And it may also highlight some areas where your your environment needs some more updates or attention in order to resolve other issues. So, and again, on the server side, the BIOS updates and the performance impact, again, will be more significant on those older systems, and again, depending on the workload. So, I think even now we have had some reports of client-side systems noticing a performance impact, you know, on the Windows side that may be related to the security patch for Meltdown, and then Spectre will probably also add to that as well. So again, newer systems won't be as significantly affected by the changes that are made to the microcode and the patching as older systems, but there will be a performance impact that will likely be felt on by those older systems. And again, Dell and other vendors are kind of going through their list of hardware and then providing updates to the most recent systems first. So so on the Dell side, if you have a 730 line or of server, you're going to get the update first. If you've got a 720 line, it may come in a while. If you're still running servers that are the 710 series, you may not actually get updates. So the vendors are using this a little bit as an opportunity to kind of tighten up their support policies and kind of only provide updates to systems that have been created in the last couple of years. So we've talked a lot about the background, the impact, the security impact that it represents, some about the process in terms of installing the updates, but the important part now is also to kind of be able to verify and validate that these updates that you've installed are in fact in place. And so, so especially if you're in the position of responsibility for managing the ongoing support and health of a network, it's important to have some tools and insight into exactly how successful you're being in patching those systems. So again, if you have additional questions or follow-up, go ahead and please chat those in. We've had some folks chatting in as we go along, and we'll have a little bit of time for questions if any remain at the end of this session. But here are a couple of tools that, or in processes that you can use to actually verify that you are protected against these vulnerabilities.
So yeah, the first tool listed there, that's at grc.com. That is a freeware GUI, or it has a regular Windows interface that allows you to quickly query and see whether or not your computer has the protections for Spectre and Meltdown. And if you're just trying to check an individual computer, that's definitely a great tool there and a little bit easier than the next one. The next one is a Microsoft PowerShell script, which is provides another level of information, and it also allows us to incorporate that testing into a management system if we're using one. So that PowerShell script, if you go to that link, it's a very Microsoft provides a couple quick commands that you can use to install the PowerShell module and then quickly run the command, and it quickly assesses and breaks down is the Windows update installed, is the hardware update installed, are the mitigations enabled, and if they aren't enabled, why aren't they? Is it because the hardware support is missing? Is it because the operating system support is missing? Or is it because the mitigations aren't enabled in the registry? So if you're on the IT side of things and trying to figure out, hey, not only am I protected, but what do I need to do to be protected? The PowerShell script is really great there. The one thing I'll say is that the terminology used in the output for the PowerShell script is not always exactly clear, and so Microsoft actually published a second KB, which I believe is linked to on that main one, but if not, you can just Google search for it, that actually breaks down and says, explains each value out. So if it says, if this value is set to true, it will say here's exactly what it means and here's what you need to do to address it. At Community IT, we use the Microsoft provided PowerShell script to incorporate that into our management system, and so we now are able to query and store in our database the mitigation status for all of our supported computers and keep that up to date as we continue to roll out these updates, particularly waiting on those BIOS updates, and be able to see, in near real time, the protection status for all of our supported computers.
Mhm. Yep. So, as Galen mentioned, the process for verifying and validating this, Microsoft is providing tools. I think, we're seeing kind of more and more, GUI tools available to provide some of this reporting as well. We use a third-party advanced security endpoint solution called CrowdStrike, and they've rolled this up into their reporting dashboard to make it a little bit easier. So, so you may have some tools in your arsenal where vendors are kind of building this reporting into their platform to make it a little bit easier to kind of see and understand to make sure that all the elements of this fix are applied. So the Windows patch, the BIOS update, and then also the registry key remediations as well. So, so we have a little bit of time to take some questions, and for folks, I think those have been chatted in. So again, the tools that we talked about, so the GRC, if you're looking to test, kind of a system or two, that's a great go-to where you can just run that application on the system itself, and you'll get a little pop-up box that says, gives you the protection status. So I guess at this point, it's expected that Meltdown should be you should be protected against if you installed updates and rebooted your computer recently. If Meltdown, is probably not, or I'm sorry, Meltdown should be protected. Spectre, we're still waiting on BIOS updates. Those are coming out now. So that's a quick check. If you're looking at, kind of system-wide, management, the incorporating PowerShell as part of your management platform may be worth taking a look at seeing at how either you or if you have an IT support provider, how they're able to check on and report about that. So one of the questions was, could you restate what you said about how community IT does with our RMM of this? So I don't know, Galen, if you want to talk a little bit about how we're actually implementing the PowerShell scripts across our client base.
Sure. Yeah. So when you run the PowerShell script, it both displays, in the PowerShell window, is this, is this protection active? Yes or no. Is this support installed? Yes or no, et cetera. So you can, view, if you're just, sitting at a computer, you can view and see what the status is. But also it, returns the result to of the properties to a Microsoft object that you can then capture and report out. So what we have in our management system is that it runs the PowerShell command, and then it says, like, say basically PowerShell result equals the command, which is get speculation settings, and then I have it output those is kind of like true false values in a way that our management system can then capture it and set the appropriate values in our database. So, for your system, I would say it depends a little bit what you're running, but in general, what you want to do is that instead of just trying to capture the, graphical input that's sent to the command window, you want to have the result go to a variable, and then once in that PowerShell variable, you can output it or store it or export it to CSV, however you need to do to then be able to gather it into your management system.
Mm-hmm. Great. Thanks, Galen. Yep. So we have, obviously with 4,000 systems, we've got to be able to automate and report on some things. So again, if you have a partner that you're working with, they likely have a similar system or maybe similar capacity they can build out to provide this additional reporting. We had a question come in about, for cloud hosted vendors, if they have been patched, kind of what do you do there? So again, it's good to just, I think, clarify the types of patching. So because this vulnerability affects basically every processor architecture, it means kind of every computer system that's running is susceptible to this. So if you're running obviously, Office 365, software as a service, Salesforce, whatever, you're just consuming the application, and there's really nothing for you to do. And the vendors themselves, are dealing with the backing systems that run those cloud services to do the updates. There's nothing really to do if you're kind of in a pure software as a service model. If you are in a situation where you are running servers, self-contained servers yourself in Amazon or Azure, or another, hosted vendor, Rackspace, whatever. There's a lot of them. Then the part that you are going to be responsible for and able to impact is the Windows side patching. But you're reliant on the vendor themselves to provide the BIOS and kind of microcode level updates, to provide that patching as well. So that information should be available from whatever vendor that you are using, and obviously they are very incented to fix and patch these issues because they are, I think, the most susceptible, to these issues where, kind of in a from a security researcher perspective, there's nothing to suggest that this exploit could not be used to exploit a virtual machine, in a cloud environment, and then it could be used to access other virtual machines that are on that same shared processor infrastructure. So there's a real need for those, for those infrastructure vendors to patch and update their systems, to eliminate the possibility that that those barriers could be broken down. Those virtualization barriers can be broken down between systems. So again, it's important to understand the systems where you have, again, the Windows patching. You should already be done. Those systems should already be patched and rebooted, and then through checking some vendor documentation and running either the PowerShell code or maybe the Inspector utility, you can get a sense of if those BIOS level updates have been applied, and then the next step may just be to deploy those registry key remediations to complete the protection process. Galen, is there anything else to add in terms of how IT staff should think about their the servers running in Amazon or Azure?
Yeah, well, I would just say, just to highlight, yeah, for them, it's for the kind of public cloud infrastructure, it's almost a not existential threat in some ways, in that, yeah, it's one thing if that video that didn't play, like if a program is able to access a password manager, that's really bad. Well, what if you're in the public cloud and you're running a server next to a bank? Well, obviously if a bank server gets exploited, that's very, very bad. So they are highly incentivized to fix it. And the reason that it's really important to look at the what your cloud provider is saying in particular is that the remediation steps required may vary based on the cloud provider. So in some cases, especially what we call kind of our tier 2 or smaller providers, a lot of times we have our web sites hosted on, say, like a Linode or something like that. They are maybe running one type of virtualization, which is different from what Amazon is doing, and so they may have different steps that they need to complete on their end. In general, on your end, you're just there to make sure that your operating system is patched. And another thinking about web hosts, if you support if your website is running on a Linux virtual private server, Linux needs to be patched too, and that's a good time to check into that or check in with whoever is supporting your Linux-based server. But in general, like at this point, any cloud provider, any cloud hosting provider, infrastructure as a service provider, they should have some support documentation available for you that indicates what they have done and what they will be doing, and what your responsibility is to make sure that your servers are up to date and patched.
Great. Well, thanks for that additional commentary there, Galen. And thanks to everyone for attending today. As always, our webinars are recorded and will be available on our YouTube channel. And so if you want to follow up, please check there. for slides and the video content. We appreciate all the questions, and hopefully you found this an informative process. I would encourage everybody to take some time to evaluate their own system, and if you're managing a network, take a look at the networks that the computers that you support to identify which systems may still be vulnerable, and also plan some time to patch and update your server infrastructure if you are also supporting that. So thanks again, appreciate the time, and Galen, thanks for joining me today to talk about this topic.
Thanks, Matt.
All right, have a great day. Bye-bye.